Numerical on method of joints. A pin jointed truss is loaded and supported as shown in figure. Identify the zero force member. Also find forces in other members and components of reaction at A and B. In this truss, force in all the members of the truss is asked. So it is convenient to use method of joints. Now at joint A there is a hinge support. At joint D there is a roller support. So at A there will be two reaction components HA, VA. At D there will be one reaction component RD perpendicular to the plane. This member is inclined. It is required to find out the angle made by inclined member with the horizontal. These dimensions are available. This side is 300 mm, whereas these horizontal members are having length 400 mm. We'll draw FBD of entire truss. Here this angle is equal to tan inverse 300 upon 400, which comes to be 36.87. Now we have drawn FBD of entire truss by removing the support and showing the support reactions with the external loadings. First, we'll apply condition of equilibrium to entire truss to find out the reaction at the support. So we'll apply condition of equilibrium, summation moment of all forces about point A equal to 0. Our assumption is clockwise movement positive, anti-clockwise movement negative. So here HA, VA are passing through A. So its movement will be equal to 0. Also this 20 kilonewton, its line of action is passing through A. So movement of this 20 kilonewton force will be 0. We'll take this 20 kilonewton. It is acting at perpendicular distance 300 and is going to create a clockwise movement about point A. So plus. Now this RD is acting at perpendicular distance 400 from A. It is going to create anti-clockwise movement, so minus equal to 0. We get value of RD which comes to be 15 kilonewton. Positive value means assumed direction upward is correct. Then apply second condition of equilibrium, summation Fx equal to 0. Our assumption forces towards right positive, forces towards left negative. So here HA acting towards right 20, it is also acting towards right, so both are taken positive. Therefore we get HA equals to minus 20 kilonewton. Our assumption, that is HA acting towards right, is coming wrong because we get a minus answer. So in fact HA direction is towards left. Therefore we can write down, therefore HA equals to 20 kilonewton towards left. Then applies third condition of equilibrium, summation Fy equal to 0. Forces acting upward positive, forces going downward negative. We'll take VA plus RD and this minus 20 equal to 0. We'll put value of RD in this equation. Therefore we get value of VA equal to, we'll put value of RD which is equal to 15. So finally we get value of VA equals to 5 kilonewton. Positive value means our assumed direction is correct. Now we have to isolate joints. First we'll isolate joint C. Now we have drawn the figure. At joint C there are two members BC and CD. We'll first assume there is a tension force in these two members. Tension force is always shown acting away from the joint by these directions. Now we can see that at joint C there is no any external force acting at joint C. We know the concept of zero force member, that if there are two members connecting at joint and there is no any external force acting at the joint, then the force in these two members is 0. Therefore we can say member BC and CD are zero force members. That is, we can say FBC is equal to 0 and FCD is equal to 0. So we got the force value in the two members which is equal to 0. Now we'll isolate joint B and apply condition of equilibrium. So we have isolate joint B. We have drawn its free body diagram. Already we have found out value of force in member BC is equal to 0, and we are assuming force in member AB is tension force. This is our initial assumption shown outward. Force in member BD is tension force. Initial assumption tension so shown outward. And here angle made is 36.87, which we calculated earlier. External force acting at B are shown. We are now going to apply condition of equilibrium. We'll apply first condition of equilibrium. Summation Fx equals to 0. This is plus 20 because forces acting towards right positive, forces acting towards left negative. This is our assumption. So plus 20. Then this FBC already 0, will not take this value. Then this inclined member will take its cos component. So plus FBD cos, plus FBD cos 36.87 equal to 0. So here we are having only one unknown, that is FBD. So value of FBD obtained is minus 25 kilonewton. So here minus means our assumed condition, that is the FBD is a tension member, is wrong. Actually this force is not outward, it is toward joint B, because we got negative answer. Therefore we can say the nature of force in member BD is 25 kilonewton, compressive, not a tension. Then use second condition of equilibrium. Summation Fy equal to 0. Our assumption force is going up positive, force is going down negative. We'll take minus 20, then this minus FAB, and this FBD. Initially our direction was outward, so its y component will be minus FBD sine 36.87 equal to 0. Our numerical value of FBD is minus 25. That value has to put, that is minus 20 minus FAB, in bracket I am writing minus 25 sine 36.87. Whatever the value we get along with the sign has to be put over here. So here finally we get value of FAB. Value of FAB comes to be again here it is a minus 5 kilonewton. So here a minus 5 kilonewton suggests that our initial assumption FAB acting outward or having tension force is wrong. Actually force in member AB is having compressive nature. So here we got force in one more member. Now we'll isolate joint A and apply condition of equilibrium. So at joint A, force in member AB, we have found out that it is a compressive nature having 5 kilonewton. So whenever we are saying the force is of compressive nature, it should be shown towards joint, that is acting towards joint A. So now here there is force FAB. This is unknown value that we have to find out. So we'll apply a condition of equilibrium. Summation Fx equal to 0. Forces acting towards right positive, forces acting towards left are taken negative. So here HA we have found that HA is 20 kilonewton towards left, that we have to put here. It is acting towards left means minus 20. Then FAD, it is acting towards right, so it is equal to 0. Therefore FAD we get 20 kilonewton. Positive value means our assumption FAD acting away from A is correct, or FAD assumed to have tension nature is correct. So it is 20 kilonewton tension. Now we have found out force in all the members. We will write down in tabular format. So we have found out force in member AB. It came to be 5 kilonewton and its nature is compressive. Then force in member AD was calculated, which is 20 kilonewton and the nature is tension. Then we have found out force in member BD, which came to be 25 kilonewton and nature is compressive. Force in member BC was zero force member, so here it is a zero force member. Also member CD was zero force member, so value of force is 0. So here in the tabular format we have shown force in all the members. Also we have found out reaction at A and reaction at B. So reaction at A was at A. The HA value is 20 kilonewton acting towards left, and VA was 5 kilonewton upward, whereas at roller support D, RD is equal to 15 kilonewton upward. So these are all the values.